state what is meant by an inertial frame of reference. First of all, what is a reference frame at all? It's a coordinate system in which measurements of position and time can be made. And an inertial means a coordinate system which moves with constant velocity, or a coordinate system which is not accelerated, or a reference frame in which Newton's first law holds, or you may say Newton's laws hold. B. A pair of detectors is set up to measure the intensity of a parallel beam of unstable particles. In the reference frame of the laboratory, the detectors are separated by a distance of 45 meters. The speed of the particles in the beam is given. The intensity of the beam at the second detector is 12.5% of the intensity at the first detector. Calculate the half-life of the particles in the reference frame in which they are at rest. So we can consider this moving reference frame to be more easier, but let's practice and let's solve this problem in a laboratory or Earth reference frame, and then with respect to moving particles reference frame. So this situation looks like this. There is the Earth, or stationary, or the laboratory reference frame in which there are two detectors, and notice that they are stationary relative to the Earth reference frame, and distance is given, it's 45 meters in this Earth reference frame. And there is a moving reference frame in which there is some particle at the origin as prime. And if we consider the Earth reference frame, so the lab frame, let's calculate time required particle to travel this distance of 45 meters, and time, it becomes what, 45 divided by 0.97 c, and it is equal to 45 divided by 0.97 and divided by 3, and it's 15.5, but 10 to negative, oh, actually it doesn't matter, let's try 15.5 times 10 to negative 8 seconds. But notice that the observer on the Earth, when he watches a particle which passes between two detectors, it will watch slow motion, and this time measured on the Earth, it will be dilated time. But we need time with respect to the particle, or it means in the frame where the particle is stationary. So we need time in moving reference frame, or it's like time interval in a moving rocket in general, and it will be proper time. So, and actually by definition, proper time, it's the smaller value, and it's a time in reference frame in which two events take place at the same point. And why S prime measures proper time? Because it's moving reference frame, and reference frame is opposite to the first detector, but particle is at the origin of S prime, and this reference frame is opposite to the second detector, but particle is also at the origin of S prime. Don't get confused. It's moving reference frame, but a particle is always at the same position in moving reference frame. So the first moment of time and the second happen when particle is the same in S prime. So S prime measures the proper time, but the observer of the Earth measures the dilated time. So time in particles frame, it will be 15.5 times 10 to negative 8 divided by gamma. Gamma is 1 over root 1 minus v squared over c squared, and it's always greater than 1. And for this situation, you can see that gamma is 4.11. So the answer divided by 4.11, and it's 3.76 times 10 to negative 8 seconds. And notice that intensity is 12.5%, and it's the value of undecayed or remaining particles. And what is 12.5%? It's 1 over 2 cubed, and it means what? 3 half-lives. So this time interval is equal to 3 half-lives. And notice that we need half-life in reference frame in which particle is at rest. So we need half-life in S prime, and that's why we have found time in S prime. And then half-life is this value divided by 3 and we get 1.25 or 1.322 significant figures times 10 to negative 8 seconds. And another way, we can consider the moving reference frame, so in particles frame, but in this frame, this distance will be equal 45 divided by gamma, because proper length is measured by the reference frame in which some distance or some object is stationary. So two detectors are stationary on the Earth or in the laboratory. So this distance measured by this observer, it will be proper length. But with respect to some observer in S primed, for this observer S primed is like Earth, like stationary, but all this or laboratory is moving reference frame, and some length measured in moving reference frame by observer in stationary, it will measure contracted length, or it's the same as if there is a rod of 1 meter, when S is stationary, it's 1 meter, but it will be measured by this observer. We will measure the length of the same rod, but if we measure it in S prime moving reference frame, we will measure contracted length. It will be 1.8 meters. And absolutely symmetrical situation, the same rod of 1 meter, if it will be measured by this observer in S prime, it will measure 1 meter to be in S prime, because this rod is stationary in S prime when it is measured by this observer, but it will measure this rod to be 0.8 meters, for example, because it is measured in moving reference frame. So this distance 45 will be contracted or will be less by gamma. But when we divide by speed, we get time time measured in S prime, and it will be the required actually proper time, and it's time required in S prime, and this time is equal to 3 half-lives. Let's check. Oh, actually, you can see it's absolutely the same. 45 divided by 0.97 divided by 3 and divided by gamma, and you can see it's absolutely the same, and then by 3. So we get absolutely the same result. And definitely this half-life with respect to the laboratory reference frame, it's a time that could be measured by this observer in the Earth frame. It will be dilated time. You should multiply by gamma if required, but we need in the frame where where particle is stationary. And C, in calculations involving time dilation, it is important to identify proper time, identify the proper time in the calculation. In the end, it's actually a definition of proper time. So measured in the reference frame of particle beam, it will be proper time, because time between two events is measured at the same place. And let's review what is the proper length. Proper length, it's the length measured in the reference frame in which given object to be measured is stationary. And that's all for this question.